Into a little bit of the why, and then we'll get into the how. So, why web workers? We talked a little bit about this. Thank you. When we talked about when we talked about decorators, where we had that sleep function, if you guys remember that, where it can actually block the UI thread. So our new hire. Oh boy, I'm so sorry, I'm blanking on his name. Who taught at Dev Mountain? He could give a thank you, Tate. He can give a great introduction to the event loop, and we should get him to do one of these just on the event loop. But the very short version is JavaScript is single-threaded. It's only got one thread that can process code at a time, and so if you do something that's too heavy, then it can block the work on that same thread that needs to make changes to the UI. And it's really interesting to me how not often that happens. And I suspect it happens a lot more than we notice, especially since we don't usually test on, say, mobile devices or crappy devices. We've all got these really fancy MacBooks. But you can always simulate it yourself. And there are certain times in your career where you're going to need to do something that's decidedly heavy, and there's just no getting around it. So I had a real-world use case for that. In a previous job, I had one just the other day here at MX, where we were processing search results. We had 5 megabytes of search index that we wanted to be able to process. And it made sense to do that out of the main thread. In fact, we did it in the main thread, and then we moved it out of the main thread, and you could see the performance difference between the two. Basically, we shaved 2 seconds off of the startup time of the application, and the app still feels as nice to use. In a previous job, we just had a really big data structure that we had to iterate over, and there was just no getting around it. We had to compute all of the unique values in all of the subfields of this data structure. And we could have done it on the server, but the server guys were behind a schedule. And so we could also do it on the UI, but not without blocking the thread. And so we moved it into a worker. Because we were using RX, communicating with that worker was stupid easy. And we'll get into that a little bit. But anyway, if you ever want to try it, the sleep function is great for that. And we played with this before, but just a quick recap. What this does is this is just a while loop that does nothing, and it spins as hard as it can until that's finished. Let's take a look at what that means real quick. So I've got a little code preloaded just so you guys don't have to wait for me to type stuff in, one of which is the sleep function. So if we sleep for 2 seconds, if I hit enter now, you can see that it's spinning for those 2 seconds before it prints the return value. And that's freezing the browser when that happens, and we'll show what that means. But you can visualize it very directly in the Chrome DevTools if you, oh my gosh, I always forget what this is. If you show, yes, performance monitor. There we go. So now we've got a little CPU ticker, so we're idling, nothing's happening. Then we run sleep, and that is all of the CPU for those 2 seconds. Well, most of it, I guess. Oh no, that's all of it. That's the top of the graph. So yeah, that is consuming all of the CPU, and that is blocking the UI thread. And just kind of watching what your app does as you interact with it, and this might be a nice way to get a little insight into something that we usually just overlook completely. And again, if you're not testing on lower end devices, you're not going to see it. There's another example, which, oops, I just opened Firefox. This is kind of the canonical web workers. My tab go? Yeah, that tab is still a little lost. Let's try this. Copy link, sweet.
Sorry, I'm not too late.
Oh.
You're too late, Lee.
We were just talking about you. I volunteered you to do a presentation on the event loop in some future date.
On the event loop?
So now you're on the hook. You can't get out of it.
All right. Event loop. It's a loop that has events.
So what this so what this is this is kind of a canonical web workers demo where we're sorting an array with 50,000 items. The thing to watch out for here, I mean, certainly we'll see it in the CPU graph like we did before with sleep. But the other thing is they try and put in a little GIF of the loading animation. If we're going to be doing something heavy, we should tell the user it's going to be a little bit. But unfortunately, when you block the main thread,
It doesn't actually render.
it doesn't, yeah, because it's blocked, right? It cannot show a GIF animation because the main thread is blocked. So there it goes, right? It took 7 seconds, and we didn't see anything other than suddenly everything froze. But with a web worker, now we get this nice animation, and everything is as interactive as it was before. You can see my hover states are working, if that's not too subtle, while that's working. And so that's a way to just farm off work to some other place that doesn't block the UI thread. And so that's really the sole purpose of using a worker, is to get work off of the thread that can sometimes block the UI. So again, we don't test on this, but we should. You can also use console time. If you haven't used this, it's well worth using just to see what it looks like. I'll show you a quick demo. If we do a console.time and some kind of arbitrary string, now we can do whatever we want to time that. And then we're done. When we're done with it, we do a console, if I can type, time end with the same string. And it'll tell us how long it took. So I was talking for 12 seconds, apparently. But this is a really nice thing to wrap around your code. And so say like you've got some kind of code that you're working on, some kind of function, right? It's doing something. You know it's kind of complex, but you don't know how complex. So I used this several times as I was working on this project here at MX where I was sorting a giant array. And we moved it into a web worker for other reasons that didn't involve the sorting, but I was still curious as to how performant the sorting was. And it turns out all of the sorting I was doing was clocking in milliseconds range. But I didn't know that until I checked. And so I just wrapped before I called my function, I called console.time, and after my function was done, I called time end, and that's it. So it's really easy to use, and it just shows up in the console. Any questions about that? In addition, there's a performance thing built into Chrome nowadays. The Firefox people have an open issue to add it under this audits tab, where they've bundled this tool called Lighthouse. And one of the things that Lighthouse can do is it can run performance metrics, and it can throttle the network and the CPU depending on devices and that kind of a thing. So again, it's not a substitute for testing on real devices, but it's a nice way that's just built into the existing browser. So if you haven't used this before, it's well worth using. Maybe, you guys interested to see a real-world demo? I could pull up the doc site real quick.
You can also use that for accessibility stuff. It's kind of cool.
Yeah, it is. That's a good point. Let's see. Nice.
Yeah, it'll actually scan the HTML and shoot out.
It'll give you a score.
It'll give you a score. Yeah. It's not
There's a lot of stuff I can't tell, but
right.
it'll
So
give you
we don't use it,
I don't know.
but it's good for like just a cursory glance of this page.
So this is the doc site that I was using web workers for here at MX, and we farmed off all of the search capabilities to the web worker. So as I'm doing that search, all of the actual logic and all of the actual data, the search index, lives inside of the worker, but it's still showing up here in the UI. And we'll kind of talk about how to do that. But anyway, coming back to this, if you go to audits, and you should do this in an incognito window so that you don't have extensions that mess it up, and it'll warn you if you do it. You come to this Lighthouse thing, and so you can say, I want to test for desktop, and at the moment I don't care about best practices or SEO, but I do care about this other stuff, and I want applied throttling. I don't have great experiences with the simulated throttling. It's always a little too optimistic in my opinion, but your mileage may vary, and these are quick to run. So then you just run the test, it does its thing, it loads the page, it performs a series of of metrics. And this is also an external tool. They're just bundling it in the Chrome DevTools nowadays. Doesn't take too long. And really all you have to do is click the button and then figure out how to interpret these results when it comes back. So you can see the performance here. And that was a little higher when I ran it last time, maybe because I'm recording and screencasting stuff. But you can see that these metrics are really, really interesting. So first, contentful paint, right? Time to interactive, right? How long before the user can start doing things. The first, meaningful paint. You know, how fast can you get something showing up on the page? So in the case of the search, we're loading a very large search index, so the user can't search right off the bat, but they can start reading the docs right off the bat. Those docs show up instantly, and then the other stuff loads in after the fact. So this is all very useful, and then this is another big one. First, CPU idle, right? How long does bootstrapping my application keep the CPU busy? And in the case of this site, there's a bunch of optimizations that we still need to do, unrelated to web workers, to just get that first CPU idle counter way down, so that the browser's not so busy, and so it feels a lot more interactive. Anyway, so you can come scroll through here, and you can dive into these individual things, and the Lighthouse, the tool, it always gives you information and suggestions. So this is a really great tool if you haven't used it before, and it's just built in. So use it. So in the past, before we had web workers, people would try and hack around blocking the main thread by pushing work onto the server, or if you couldn't push it onto the server, if you had to do it on the client, this was a common way to do it, where you would find some way to break up the computation into chunks. We're going to do this chunk of data, then this chunk of data, then this chunk of data, using just awful, you know, if this doesn't look awful, then yeah, I think this is self-explanatory. So yeah, to get the whole thing done without blocking that main UI thread. But now we have web workers, and we've had web workers for a really long time. They're one of kind of an undersung hero, I guess, kind of like server-sent events, right? They're very simple. They're pretty easy to use, and we've been able to use them for quite a long time. They're supported on all browsers we care about, and they've got some crazy features going back to IE10, all mobile browsers, right? Like there's no reason not to use them. So how do we use them? That's it. You create a new worker, which spins up a new thread that you can then communicate with by calling this API with a path to a script. Now there's some nuance here, and we'll go into it, but that's the crux of how you start up that thread. You can also do something that involves stringifying functions. So in this day and age of Webpack and bundlers, this is a little harder to work with than it used to be. And we'll get into kind of pros and cons or how to deal with that. But if you don't want to put code in a completely external script and have that loaded as a specific web worker, you can do stuff where you stringify a function, you wrap that in a little blob binary, you ship that over to an empty worker, and then run it inside of the worker. And it does work. And for self-contained functions, it's not a bad way to go. Just keep in mind that the thing that you're doing is definitely a hack, and there's going to be weird things. So like we did this at my previous job. And what we did is we had an empty worker that could run just generic functions, and it had Lodash available because we use Lodash a lot. And the Lodash import was available in these stringify functions as something totally different than what you would expect because of the bundler we were using, Webpack. Webpack would make Lodash available in a very particular way, and when you're using Webpack, you don't see it. But when you're not using Webpack, or when you're half using Webpack, you definitely see it. So if you do this, just keep in mind there will be dragons. And so when you do this, it's async. It's going to load that worker up asynchronously. So if your worker is doing something heavy, it's initialization. If your worker is loading additional external scripts, you're going to want some marker to say when you're ready, when your worker is ready to start receiving messages. And we'll talk about that. But keep in mind, loading the worker is asynchronous. So there's a limited collection of things that you can do inside of a web worker. You cannot touch the DOM, but you can do these things. And and they come up. So making HTTP requests is kind of a big deal. And there's this built-in way to import external scripts, which we'll cover, which is kind of important. You can create other workers, which is kind of nice. And otherwise, it's pretty standard JavaScript as long as you're not trying to mess with the DOM. And then after that, you're just sending messages to and from the worker. And I mean that very literally. That's the only way to interact with a worker is to send messages. And what the format of those messages look like is entirely up to you, but you're sending messages. So the data that you're going to necessarily send between a worker and the main thread, so in our case, say search results, is going to be copied. So you used to have to JSON stringify it yourself. Nowadays, that's built into browsers. I meant to look that up for this presentation, and I forgot. I'm sorry. But I don't know how far back support goes for not having to stringify your own objects, but you used to have to. But essentially, you're copying the data in the message. So you build the search results. You send the search results and the message as a copy of that data. So we're making a JSON stringified copy of that data that then we can use to draw the DOM. So keep in mind that you're copying that data, and you should probably get rid of it when you're done with it once it's copied, unless you need to hang on to it for a specific reason like caching or something. You can also transfer data, and if you transfer data, this JavaScript engine will physically take away your access to the thing that you just transferred. But this is only useful for binary data. So like if you're generating images in a worker, and then you want that image to be available in the for rendering into the DOM, that would be a great use case for transferring this binary data. I looked into back in the day. I was curious if there was a performance difference between doing a JSON stringified copy and doing and trying to transfer that data instead. But you still have to JSON stringify it, and then you have to wrap it up in a blob object. So it's more expensive to try and transfer something that's just an object. So really, I think the takeaway is binary data is transferred, everything else is copied. And we'll see what that looks like. You can also import scripts like third-party libraries. This is really cool because this is something that no other place in JavaScript in the browser, this is not built into any other place in the browser until very, very recent builds of Chrome, where we've got support for import and the new import function call. So this works back to IE10. We've had script importing since IE10, and nobody knew. But it's synchronous. So that part is a little weird, and you just have to keep, it makes sense in the context of a worker, but keep it in mind because it might not make sense for JavaScript, since everything else is asynchronous. Back to IE10. All right, so the guy who did the JavaScript Jabber interview is well worth listening to if anybody's interested, if you guys are podcast people. It's a good interview. They didn't go as deep as I would like, and we're going to cover some of the questions he didn't answer here, namely how to do things in them, not just what they're good for. But he was pretty gung-ho on workers, and it's hard to disagree with him because they're so widely supported. He thinks you should put absolutely positively everything inside of a worker. If it's not directly drawing the DOM, it should be in a worker. And on one hand, I don't think that that's a bad call. On the other hand, we've got so much momentum and tooling problems like bundlers that make that kind of difficult. But if you're greenfielding something, if it makes sense given your existing app architecture, yeah, why not? Put it in a worker. There's not a lot of downsides other than just trying to get it into the worker. If you come up with a nice messaging system, then you've basically got Redux anyway, and so it's not out of your workflow of what we're already using here. But if you do use third-party libraries, that's where you're going to run into a problem with a bundler. So at my previous job, I didn't do this very well, and I bundled a separate copy of Lodash with the bundle that gets run on the worker and then the bundle that gets run in the main app. So we were shipping Lodash to the client twice. So you'd want to use something like Lodash's, Webpack's flags to say put Lodash in a Lodash specific bundle, or Lodash and RX if you're using both of them, and then have both your main app use that and the worker use that. So, and I'll show you why that is. But yeah, third-party libraries are going to get a little tricky. So now on to the demo. Any questions before we do? So I've pre-written a few things just so you guys don't have to watch me type. So let's walk through what I've pre-written. And I've used all vanilla JavaScript. So hopefully it'll be easy to talk about. So we've got an HTML file. It's not doing anything. I've gone ahead and put a form in here for reasons we'll get to. And then we're loading a JavaScript file, and we're also loading a couple of libraries. I put these in the head just so that these two libraries are available before this one executes. This isn't something that you'd usually do if you're using Webpack, but just an implementation detail for the demo. Interrupt me if you have questions about that. So here's the JavaScript file. So presumably this is the thing where all of your React code is. You know, this is the thing that's calling React render. And so we're initializing a worker that's going to live in worker.js. And then we're setting up some event listeners to talk to our worker. In this case, we're setting up an event listener right on the worker object, listening for the message event. And we're console logging everything that comes through. So there's a variety of ways you can architect an application using web workers. And this is one possible way. My previous job, and something that I think would make sense here, is if you're using RX, you probably wouldn't want to do this. You'd want to wrap it in an observable. So every time you get a message from the worker, it's just part of a stream. Then you could have a reducer listening to, doing the normal filter and listening to the parts of the stream that it cares about. Everything else that's in here I kind of copied from just our Redux architecture here. So we're just doing a switch statement on the tag that comes through, and then we've got the tag and the data, and that's it. Any questions about that? And we're doing these namespace tags just so that we can do a variety of tags and have our worker listening to those. I forgot to. Is that better? Let's see. Yeah. So that's it. So this is kind of a dispatch scenario where we're listening for certain tags. When a certain tag comes through, then we call a certain function, and that's it. On the worker end of things, we're doing the exact same thing. So this is the worker, where I'll circle back to the. I'll circle back to that. But basically, our worker is doing the exact same thing. Setting up an event listener. I've got some try-catch logic, but otherwise it's the exact same switch statement. So if the worker gets something that it knows about, it calls that function, returns the result of that function back with another tag. So if you get my worker slow task start, it will respond with my worker slow task result. Okay? If you send it something that it doesn't know how to process, it'll reply and say it doesn't know how to process it, just to make debugging easier, right? If you typo an action name and this way the worker will tell you. And again, we're console logging everything that comes through on this side too. And then we're just sending the results back of whatever function we call. So that's the worker. And that's really all of the scaffolding you need to put up to get this working. And so I hope this is sufficiently minimal that you can kind of wrap your head around how you would use it, and not how you would use it and still have it be kind of a big mess. Hopefully this provides enough structure that it's similar to our existing kind of Redux workflow where we're dispatching reducer functions.
So is this worker sent or worker received?
This is, that's a good question.
This
yeah.
is the worker itself, right?
This is the worker itself, so this would be received. Thank you.
So this is, the highest level you create a worker, then you add a message listener on the worker, or messages that it's sending, and then inside the worker, you add a message on itself for the things that it's getting, and you're just posting messages.
Yeah, on both sides of the exchange, you've got this post message API. So the worker is going to post messages that are going to be available back on the main thread, and vice versa. So if you want to send a
And those messages have to be, are they just the same as like a couple of Windows post messages, just JSON essentially?
Yep. Yeah, you can put whatever you want in there. So for us, we're sending an object that has a tag and data, but you can send whatever you want. And that's the part that's sufficiently open-ended that maybe a lot of people, certainly new people, would say, well, I see how to use it, but I don't see how to architect an app around it. I don't see how to make use of this in a real-world setting. And so hopefully this provides just like the minimal amount of scaffolding to make that clear. Because you don't need much, right? If you've got nice messages back and forth, then you've got that. Let's see. Sending data to worker. Nope, I had it right the first time. Let's see, and this is the worker file, so. Oh. I had it right the first time. Sorry, Sam, that's a little confusing. So I'm saying the worker sent, let's see. Oh no, this is the worker received. Yeah. So if we refresh the page, yeah, we're not sending anything to the worker, so let's do that. So now let's do, looks like I had a placeholder in there. Let's see, off the top of my head, I would expect this to show up after the worker has mostly initialized. I guess we'll see if I'm right. So what's going to happen is we're going to initialize the worker asynchronously. The worker is going to start doing whatever appears at the top of the file immediately, and then we've got that event listener that happens. So I guess it depends on when the event loop turns. I certainly wouldn't rely on this kind of ordering, though. So worker received, yeah, after we get the loading. So let's look at what the worker is doing in terms of initialization.
Did you say that the worker is initialized asynchronously?
It does. The worker, the file is loaded asynchronously, but once the file is loaded, the things in this file are processed synchronously. So let's go through that. The very first thing we're doing here, self is optional. It's a global variable, so you don't have to prefix everything with self. I like to be explicit because I have a Python background, but that might be less popular here at a Ruby shop. So as soon as this file starts executing, it's going to fire off that it's loading, right? And if you're loading external scripts or if you're doing something expensive, you might want to do something like that just so that the main thread can catch that and maybe throw up a loading spinner saying, we're definitely working on something, hang tight. But as we've talked about, their UI won't be blocked while they're waiting, so that loading spinner will be just fine. So in this case, these two things are both synchronous. It will load Lodash and load Rx synchronously, and then we're going to go ahead and say, okay, it's ready, and to prove that it's ready, we're actually going to use Lodash to uppercase the event. So that's the initialization logic that we're working with, and you can see that reflected in the console here. So loading happens, oops, then ready happens, and you can see that's uppercase. Lodash is uppercasing that. Then the event loop turns, we get that message there. So in a real-world application, what we'd probably want to do is have something set up, have an epic or some kind of Rx stream that's listening for that ready tag, or the ready and the loading tag. So sees loading, throws up a spinner, sees ready, now we can start sending messages to it. That's what I did in the search results because we were loading 5 megabytes of JSON of search index into the worker, and it doesn't take very long, but it certainly takes long enough that you would want to care about race conditions. And so I fired off a ready tag when the search index was done, and then that's how I knew when it was safe to start sending search queries to my worker.
When you say, just to make sure, when you say it's synchronous in the other thread.
Yep. So let's talk about that. Let's talk about exactly that. Let's see. Let's talk about loading scripts since we're here, and then let's actually do some synchronous work in that other thread. So you can see that we're loading Lodash and Rx, and we're loading Lodash and Rx in our main app too. So what we're going to see is I'm going to turn off the performance monitor if you guys don't mind. We're going to see that our worker is doing this, and Chrome has this nice thing where it prefixes it with a gear icon if it's inside of a worker. So you can see that we're loading Lodash and Rx twice, but that's because I'm disabling my cache. If I do that and then I shift refresh so that I'm still starting with an empty cache, you can see that the browser loads Lodash and Rx, but then when the worker loads it, it sees that the browser has already loaded it, and so it's working off of the cache. So this is one of the reasons that you'd want to set up your Webpack to, say, build a bundle that's shared between your worker and whatever else, the main thread, because you can take advantage of that caching. Definitely speed things up. What else was I going to say about that? Anyway, the scripts are loaded in parallel, but the worker waits until both of the scripts have been loaded before it continues on processing. So again, the import, the kind of module story in JavaScript is all over the place. This doesn't help that, even though it's still nice to be able to use the feature. But yeah, so import scripts will load the scripts dynamically, but block execution. So if I put something like this, in between the two, we should see that show up in the expected order here, where loading, still loading. Now we've got Lodash, so synchronous execution. All right, now let's do something that's long running in our worker, and let's look at the synchronous execution there. So I copied our sleep function from before here, and what I'm going to do is I'm just going to call it a bunch of times. So I'm going to sleep for 2 seconds as the worker is initializing. Maybe we're doing something expensive, you know, like indexing search results or loading and indexing search results. I'm going to sleep before we load our things. I'm going to sleep after we load our things. Yeah, so that's an awful lot of sleeping. That's 2, 4, 6, 8 seconds worth of work that our worker is doing. And you can see that the main UI thread here, it's still doing stuff. It's still reacting to things while the worker is doing its thing. Actually, those console logs output way too soon. Maybe I didn't shift refresh. Oh, I didn't because let's turn that back on. All right, there we go. Starting over. So it took 2 seconds before it did the loading. Before that was pretty much immediate. Another 2 seconds before it got Lodash, another 2 seconds, right? And in the meantime, our thread is still fine. And if we pull our CPU monitor back up, more tools, profiler, nope, not profiler. More tools, performance monitor, there we go. And we refresh that. You'll see the console log messages output from our worker. But aside from that initial kind of loading the app spike, the CPU is not getting spiked even though we're doing that 2-second spin, whereas it definitely got spiked when we did it here, for those of you that came in late. See, if we're sleeping for 2 seconds in the main thread, you're going to see that on the CPU. And let's talk about interactivity. So let's spin for 8 seconds. while we're spinning, I can't click anything. This is what I mean when I say the UI is blocked, right? I can't resize, I can't click, I can't type. And I definitely broke it because oh no, it submitted the form for me. It remembered my button press. How nice of it. So yeah, the UI was decidedly blocked. Whereas while the worker's doing its thing, it's decidedly not. Okay? So is that clear with the sleeps and the import scripts, how that's executing synchronously with the console logs? And it's awesome that all of those console logs just show up in the main browser console. If you ever want to drill down to the worker specifically, this is kind of a not well-known part of Chrome. But this little drop-down, if you've got an iframe or, in this case, a worker, you can drill down onto just that context. And so now you're just dealing with that worker context. MX tip, if you like to listen to audio or video at a slightly faster speed than normal, all of the videos in MX University are embedded in an iframe. So if you wanted to do, like a query, like document query selector for video, to change the speed to 1.5 or 2x, you have to do it in the other context of the iframe, but it's right there. So just drill down, and now you can listen to MXU at 2 times speed.
Gotta make an extension for it.
Yeah. And that's really it. Let's see. Should we try to modify this so that we're doing slow task start, slow task result? Let's do. Actually use ES6 in this context. Let's see. Actually, sleep return stop. Let's just do that. Okay, so now we should be able to send our worker this and get a result back. I didn't test this, but I'll see if I type out anything. So we're going to do this back from our main context. Oh, it's complaining that it couldn't clone our console. No, let's see. That's not what I need to do here. Oop, lost it. Result is what we're actually serializing. Sleep should return a string. So that should be serializable. No, it's complaining about not being able to serialize the function. Let's try it. Oop. Starting long task. There's our result. I'm done. Looks like I forgot to, looks like I made a function called handle result, but you can see in the console log, it did what we were expecting. Questions about that? while it's sleeping for 5 seconds or whatever we told it. You can see the form is still plenty responsive. And then we get the other result back. So they are pretty simple to use. And that's it. The guy on the podcast, he said that all of your Redux, all of it, should be inside of a worker. And given how we communicate with Redux, it would be a really seamless change, architecturally. I'll bet very little code would have to change other than the ingress and exit points of the messages that are sent to and from Redux. I'm not saying we should, but yeah, I mean, if you were greenfielding something.
Yeah, I've never actually been blocked from the Redux thing here. Obviously, we had that problem with SaltStack. That was obvious. Jenna honestly blocked since React is rendering so much. Just interesting.
Refilling wiring in Redux today. So I'll go to this
Nice.
I mean, it would only matter if you're doing some gnarly stuff in Redux, right?
I don't know. That's a good question. How gnarly does it have to be before it's in a web worker? If you have the opportunity to greenfield it, and it doesn't cost you anything to move something into a worker because it was there to begin with, then you might as well, right? There's no downside for doing so, and that frees you up. Or maybe you only want to put the stuff that you know is definitely CPU intensive into a worker. But when you do that, because you have to put the worker stuff in its own file, unless you do the crazy stringified approach that we talked about, now you've got this dilemma of you're kind of arbitrarily carving up your utility functions or your reducers or whatever it is into reducers that are slow and reducers that are not slow. And now they live in different places, and that's weird. Whereas if you could just have all of the work happening in one place, maybe it's worth it from that vantage point alone.
Yeah, I think the hardest part, or the weirdest part, maybe would be getting the dependency thing straight with Webpack and everything. Start getting into trouble there.
Yeah, that's definitely true. Yeah, if you need a library available to your worker and available to your thing, then getting that Webpack configuration right off the bat is crucial and annoying. I don't know, like bundlers, I mean, they solve a real problem, but they also create an awful lot of real problems.
Yes. But I think that would probably be the weirdest part, is trying to get that right and not painful. Especially later down the line, you're like, so you're Webpack config, and now you're like, writing report scripts. I wonder what that would look like.
I think it'd be worth doing a quick proof of concept of sharing, say, Lodash and RX between both.
Plus, yeah, it's weird because in Serenity, I can't think of a single case in which a reducer was the problem. Like, it's always if our UI is locked up, it's always because React's rendering always. Well, at least it's always been on animating things in. Well, I guess yeah, we're not batching. Like we had the batching problem, which was kind of Redux, but the webmaster probably wouldn't save you from that. If you're messaging 10,000 different, if you're dispatching 10,000 individual updates, you're still going to get screwed on the other side because you're getting 10,000 back. That would be pretty interesting.
So this isn't something that a worker would solve, but I push back on a little bit on the problem of Redux or of React rendering too often. This is the problem that we initially saw at Salt, where it was just trying to render complex things too often, and the solution was, I mean, in vanilla React without Redux, you don't have the option of separating state changes from renders. If you change the state, you trigger a render. That's baked into the anatomy of React, and that simplifies the API for React because That's one less, pretty big problem that you don't have to keep track of anymore. But oftentimes you do want to do complex state things and not trigger a render. And this is something we definitely saw at Salt. And when we see the problem of React updating too much here, it's the same core problem where ideally if you could move that work into a reducer. So the reducer is cobbling together data from a variety of sources. And it's saying, I'm not going to render until I have the entirety, right? And you can hack around this in React, but it's not baked into the React API because you have to keep that kind of in progress state somewhere that is not set state, out of the component state in order to efficiently do that. And with Rx and with epics, we can do that. If you need data from a variety of places, that's a simple combine latest operator where you've got one of the things that's in combine latest is waiting for an AJAX response, and that's not going to block the UI thread. And you've got another one that's doing something crazy with multiple other reducers. And maybe one of those will block the UI thread and the other ones won't, but you definitely don't want to render until you've got those three and this one AJAX call. And the combine latest just magically in one operator says, we're not going to render until we got everything. That's it.
Well, the other, because React rendering, but where it's a problem with Redux is if you do like filters and maps and a map saves props, you're screwed because you're probably will update every single time your information changes. But that is just a remedy. We had a very real problem to solve, obviously. There's no way we could have done that grain thing in the UI thread ever achieved 60 FPS. But it's interesting. I like how simple the web workers are. It's just PubSub, right?
Yeah, it really is. And if you're using Rx on the other end, then you don't care how long it takes. It's like making an AJAX request. You can treat talking to a web worker, whatever the web worker has to do, like an AJAX request. So at Salt, we had this gigantic array. It was a collection, so it was an array of objects, and the array was 50,000 long, and each object was pretty long itself. It contained 100 data points, give or take. And basically, we needed the unique sum of all of the data points in each line in the collection. So there was no way to collect that data other than iterating through this array of 50,000 things and then iterating through each object and grabbing all of the keys in each object. So it was going to take a while. And we put it in the main thread, and it took a while, and it locked the UI. And then we moved it to a worker, and we just pulled it in via Rx. We were just listening to that message with Rx. So the application code that needed to change was like 5 lines. We were doing this, and now we're just listening for this message. We're just flat mapping this message from the worker, and suddenly the UI didn't lock, and it was like magic.
Keep that in mind.
If I take a stab at the Webpack config, maybe I'll Webpackify this POC. I'll post it in the mind.
I'll buy anybody lunch. Or good. We have solved that problem so many times, and then it drifts away. And then why do we have 5 copies of Lodash? We did it 1, and it's like, why are we back at 5? It's just crazy.
It's almost as if just loading the entirety of Lodash once and having the browser cache the crap out of that wasn't a bad idea to begin with.
I'm almost ready to do it. Because what we have is worse. It's like, yeah, you load it. Like, Lodash is just a dependency for graph, period. Everything uses it. So just like have it there. I wish I could figure out how Webpack chooses to chunk stuff. Because it seems like it just tries to figure it out. It's like, well, you did it wrong. And I don't know how to change it. And then you just change a bunch of stuff and then find it works. And then 6 months later, it's like, right back to where it was.
I wonder if we'll start to see a pushback on bundlers and return to monolithic script tags. Now that we're getting native import starting to show up in the browsers. Because I mean, if you need a proof of concept like we're playing with today, you just call import and you got a promise with your library, and that's it. And that's even simpler than it was back in the day, because now you don't have to worry about putting things in the head or putting things in the body, right? You've got a promise, so you can control when it's available to your app. So I wonder if we'll see a pushback. And if we finally get around to adopting HTTP2, then I don't think there's any reason to use bundlers other than tree shaking. But nobody seems to do tree shaking
It doesn't
well.
work.
Yeah.
we like tree shake, and we just end up with like 5 different bundles of the same copy stuff. So overall, it's worse.
Yeah.
And like, I fixed it like 6 months ago, I think. When I went through Webpack 4, and we were down to like 200, depending on like what you asked for, you get 200 to like 500K of stuff. No one has touched the Webpack file in 6 months, and we're up to a megabyte. No one's touched them. Like, we've added dependencies, but none of these dependencies are that big. Like, we've added really small libraries, and like all of a sudden, when you look at a bundle analyzer, it's like a bundle wrong. So nobody has changed this. We've not upgraded versions, but for whatever reason, Webpack's like, here's all the chunks, and the smallest one's a megabyte. Well, it wasn't 6 months ago. Like, what's going on? I would seriously buy lunch. Anybody who wants to fix that for real. Because it's a thorn in our side. Especially
lunch
when
is
it's
a
big enough for the board. It is.
Launch in 6 months.
Lunch for 6 months. Yeah. It's a very tough problem. And a lot of black magic there. And it is a problem for our users, especially on mobile devices. Letting a megabyte of JavaScript seeds.
It's the state of the web. It's continually on the verge of, well, the thing we had now is better than the thing we had before, and there's this great thing coming down the pipe. So I guess I'll still program JavaScript for a little while. It'll get better.
It will. And maybe we're probably doing it.
I can guarantee we're doing it wrong. It's just nobody knows how to do Webpack.
It's like
Not
juggling
even the
plates.
creators of Webpack.
I really would actually like to go back to if we just like bundle, we could stop trying to be smart about it. It's like, look, if you're going to surrender, you're getting React, you're getting React on, you're getting Lodash, and you're getting RX. Like, don't try to be smart about it. Like, here's all of our biggest dependencies. And those are just a bundle, and you have to have them. And then just say,
Like
like,
React scripts.
what was that?
Like React scripts would be great right now.
Oh, well, that's,
It's a bunch of dependencies.
yeah.
So it'd be like our own.
Yeah, and I'd rather just say, like, we have that,